So in this lesson, we're going to be talking about deriving different formulas that we've learned in this unit. The three formulas are the law of sines, the law of cosines, and this formula for the dot product and the magnitudes and the angle between them. Now in class, the group is going to derive this formula with some prompting from me. And then for homework, you're going to do the other two formulas. You're going to derive the other two formulas. And again, there'll be prompts along the way to get you going. So in this video, I'm going to try to mimic what would have been done in class, but I encourage you to pause at certain places and try to do the work yourself if you can, and then check to see how you did by following what I did. So we have some instructions here. We're supposed to draw two vectors of different magnitudes and different directions so that both vectors start at the same point. Keep the angle between them acute for simplicity, and then label the vectors A and B and the angle theta. So what I'm going to do is I'm going to have you pause at this point and try to do this on your own, and then when you are done, you can then restart this video and see what I did. So here is the diagram that I got, and yours should look something like that. So step B, in your diagram, draw a vector C that goes from the end of A vector to the end of B vector. And again, I'm gonna have you pause the video and do this yourself, and then you can see how I did. So here was the end of A, here's the end of B, and I drew the vector C that went from the end of A to the end of B. All right, so step C, using the magnitudes of these vectors, write out the law of cosines that uses cosine theta. Pay attention to which side is opposite the theta. Now notice that this formula will include magnitude of A squared, magnitude of B squared, etc. So there are magnitudes everywhere in the formula. Now once again, I'm going to have you pause the video and try to do this on your own, and then when you're ready, you can check to see how I did. Now the first thing I'm going to do is I'm just going to write the law of cosines formula here, noticing that theta is basically opposite of angle of vector C, so it would be the angle C in this scenario. So this would what be the law of cosine if these were all just lengths. The problem is there aren't lengths here, there are vectors. So basically a length is the magnitude of a vector, so instead of the letter C, we just use magnitude of C and then squared. Magnitude of A squared, magnitude of B squared, minus 2, and then magnitude of A, magnitude of B, and then cosine of theta in this case instead of angle C. So this is the equation we're trying to get for part C. So the next step is, from our diagram, show how C vector can be written as negative A vector plus B vector. And I'm going to, again, have you pause the video and then do it and then check your answer when you're done. So again, C vector starts here and ends here, so this would be the shortcut, but another way you could go is to go from here to here and then to here. So from here to here is just negative A, and then from here to here is B. So the path, the shortcut path C is the same as doing this long path negative A plus B. So that would be a way to describe what we just did. So the next thing is, let the component forms for A and B be the A vector is UV and the B vector is XY, and then using these components, write the dot product A dot B. And again, pause the video and then check your answer when you're done. And of course, you should have gotten A dot B equals UX plus VY. All right, so step F, it says using parts D and the components in part E, write the component form of C vector in terms of U, V, X, and Y. So part D, we found this. Part E, we were given these components. So now we're supposed to find the component form of vector C. And again, I'm going to have you pause the video and then check your answer when you're done. Okay, so what I did was I just took the equation c equals negative a plus b and vectors, and then I plugged in the components u, v, and x, y into the a vector, b vector, distributed the minus sign, and then added like terms, or x components, y components, and I ended up with this. Now, this is technically the correct answer, but a slightly nicer way to write it might be to do it this way. Instead of negative u plus x, it's better to say x minus u, and so on. But this is an acceptable stopping place. So the next question says, the magnitude of A can be expressed as magnitude of A equals square root of u squared plus v squared. Of course, we know that formula. So that magnitude of A squared, the square root will go away, it's just u squared plus v squared. In a similar way, find expressions for the magnitude of B squared and the magnitude of C squared. And again, I'm going to have you pause the video, get the work done, and then check your answer when you're done. So, of course, magnitude of b was square root of x squared plus y squared. So the magnitude of b squared will just be x squared plus y squared. And then the magnitude of c, and I use this version, but you could just as well use this version. Very carefully use parentheses, though. Square root of, and then quantity x minus u squared plus quantity y minus v squared, right? Because each of these components is being squared, put parentheses around them. So when you square that, you get magnitude of c squared is just parentheses x minus u squared plus parentheses y minus v squared. So again, the parentheses are critical there. So next, we're supposed to go to our equation from part C and substitute the expressions from part G into the magnitude of a squared, magnitude of b squared, and magnitude of c squared. Leave any other magnitudes that are not squared alone. And this was the equation that we had from part C. So again, I'm going to have you pause the video, do what you think is the instructions are here, and then check your answer when you're done. So, magnitude of c squared was this. So x minus u quantity squared plus y minus v quantity squared. Magnitude of a squared was this. So u squared plus v squared in that spot. Magnitude of b squared was this. So x squared plus y squared in that spot. And then the other magnitudes are not being squared, so we were told to leave the other magnitudes that are not squared alone. So I'm just going to leave all that alone. So minus 2 times magnitude of a times magnitude of b times cosine theta, just left alone. So the next thing we're asked to do is expand out any binomial squares in this equation. So again, I'm going to have you pause the video, do the instructions, and then check your answer when you're done. So this is a binomial square, and I'll get x squared minus 2xu plus u squared. This is another binomial square. I'll get y squared plus y squared minus 2yv plus v squared. And then everything else, there's no more binomial squares, so I can just copy it down. So here's the result we had from part I. Part J says, notice that some terms will cancel from both sides of the equation. Cancel them. Then divide both sides by -2. So again, I'm going to have you pause the video, do what the instructions are telling you, and then check your answer when you're done. So you'll notice here x squared and x squared will cancel, u squared and u squared will cancel, y squared and y squared will cancel, v squared and v squared will cancel, and so all we're left with is -2xu minus 2yv equals -2 absolute value, magnitude of a, magnitude of b, cosine theta. So that's what I kept. And then all of these terms are multiplied by -2. So if we divide everything by -2, we just get xu plus yv equals magnitude of a, magnitude of b, cosine theta. So the final instructions are to compare this equation, the one we just found, to your answer from part E, which I put over here, and substitute appropriately to end up with the formula that we're looking for. So again, I'm going to have you pause the video, do what you think is being instructed, and then check your answer when you're done. So xu plus yv is basically the same as ux plus vy. So this thing over here can be replaced by a dot b vector because they are the same. So it's basically a substitution. And so you end up with the formula once you've substituted the a dot b in this side. And that is the end of the lesson.